And today we're going to talk about ARP vulnerabilities. I don't know the session previously. I know that was also about ARP and things you can sick by the end of the day. Based on some tools and toys I've been writing over the last few years, mostly as a result of poor coding practices and screw-ups and everything else, I found you could really abuse ARP at all different layers. So, with respect to I'm going to quickly go over ARP. We already went over that a lot in the previous session, but for those of you who aren't here, we'll go over it again. Describe the basic ARP vulnerability. Describe the 2 or 3 basic types of attacks. And then we're going to talk about what systems are vulnerable, what different types of operating systems, as well as network devices. I'll describe some of the different types of countermeasures you can use, some of the different detection mechanisms, and then talk about the existing public domain tools and utilities that are out there, as well as some of the ones I wrote, and then we'll try to do some demonstrations at the end. So, and also if you guys have questions, we're going through this, please don't hesitate to stop and ask. Okay, so quickly at the most basic form, okay. All right, we have too many cables up here. Okay, basically, ARP really performs the function of translating or mapping IP addresses to the MAC or lower level Ethernet addresses. It's more or less the protocol layer addresses. An ARP header is 28 bytes, and obviously when you map that on top of an Ethernet, the Ethernet actual header, which is 6 and 2 bytes, it's a pretty small packet. There's 6 general ARP messages. There's ARP request and replies, reverse request and replies, and inverse request and replies. They all do different types of mappings between IP addresses and the MAC addresses. We're really going to focus today on the ARP request and replies. Okay. Now, the general basic ARP request message is fairly simple. All it does is it contains the source IP address of the system requesting the information, the system's MAC address or Ethernet address. It contains the destination IP address and then the broadcast MAC address. Okay? So basically, when a system, say, wants to ping another system, it builds a ping packet, it travels down through the stack. When it actually tries to go out onto the Ethernet wire, it does a lookup in its ARP cache. If it has an ARP entry in there already or a MAC entry in there already, it'll just take that, plug it in, send the packet on its way. If it doesn't have an Ethernet address, it basically builds its ARP request message, sends it out to the system across the wire. Each Ethernet NIC will actually look at the packets going by. If it's a broadcast, it'll ignore it unless it's its own IP address. If it's its own IP address, it'll basically pick it up, generate an ARP reply message, and send it back to the destination system. At that point, the system will basically build up and cache the IP address and the MAC address, and then send the packets on its way. So it's very simple, stupid. It happens all the time without anybody thinking about it. Now, the key problem here is that there's no authentication whatsoever with ARP messages. Okay, any system anywhere on the network, if they can see ARP traffic, can spoof replies to it. Now, the big problem is if you spoof a reply from one system to another, and there's already an entry in the system, it's going to overwrite it. Okay, because it basically takes the newest ARP entry first. If there's not an entry in the system, most systems will just actually add that entry blindly into their cache. Okay. It's been called ARP poisoning, cache corruption, ARPL. There's all sorts of different names for it. Now, as far as different types of attacks, there's really 3 general types. Obviously, sniffing attacks and session hijacking are more or less related, but denial of service attacks will go into a lot more detail, and you can have all sorts of fun with those. Now, sniffing on a hub is a very simple, stupid picture. Obviously, if you have a hub network, you will basically see all the traffic, all the unicast, broadcast, and multicast traffic. Now, switch sniffing is a little bit more of a pain in the neck. Obviously, in switch networks, you're going to see the broadcast and multicast traffic, and you're only going to see traffic destined for you. Okay, so just unicast traffic destined for yourself. All the traffic going through the switch is basically passed based on the MAC address, the source and destination MAC addresses. Okay. With respect to actually compromising a switch network, what you need to do, or the attacker needs to do, is basically fool the switch and the destination and the source of the connections into sending all the traffic through you. And then the poor system actually has to pick up the packets and forward it on to the destination. Now, here's a quick example. If client is talking to the server, basically, again, the client will generate an ARP request, broadcast across the wire. The server will pick it up and generate an ARP reply. Now, the hostile system will also see that ARP request going across the wire as well. What it's going to do is it's going to generate its own ARP response to that packet. So it's going to basically put the server's IP address into the packet, its own MAC address into the packet, and send it back to the client. And it'll also probably do the same thing to the server. So the client may receive the server ARP reply first, and it's going to cache it. But then it's also going to receive the hostile ARP reply packet as well, and then that packet will actually overwrite the existing entry. And the same thing for the server. So at that point, you can actually control all the traffic between the client and the server on that switched network. Now, if a host says is somebody going out to the internet, so they actually have to go to a router, the same process applies. Basically, the client realizes that the destination is not on its local network. It will forward it on to its default gateway, which is probably going to be some type of router. The hostile host does the same thing. Basically, picks up the message, spoofs the reply back to the client, and spoofs the reply back to the router as well. And yes, the routers will actually cache the bogus replies. And then once again, the client will basically be relaying all the information through the hostile person and then back out through the router, and vice versa. So here's a simple relay configuration. We have an attacker on the wire as well as good old Alice and Bob talking to each other. The attacker has actually spoofed the MAC addresses, as you can see in the bottom, in the lower gray boxes. So you'll notice that the MAC addresses for Bob and Alice's cache is actually the attacker, and the MAC address in Bob's cache for Alice is also the attacker. So when these two systems are talking to each other, everything is actually being passed through the attacker, and the attacker then actually has to repackage the packet and forward it on to the destination. And here it is more or less with arrows. So you can see the sniffer, the attacker, really has kind of double duty. It not only has to pick up the packets and look at the packets to gather the information, but also has to repackage the packets, fix the MAC addresses, then forward the packets on as well. Now, some things in terms of actually using tools like this. There are a few systems, one at least, which we'll talk about in a minute, where the cache cannot be corrupted for some reason. I'm still trying to figure that out. Okay? So think of a simple telnet connection. Okay, it's bidirectional. Everything you type gets echoed back to you. So even if you can't actually corrupt the cache on that target system, you're still going to be actually corrupting the cache on one end of the stream. So you'll still actually capture at least half of the stream. You may not capture everything coming back, but you'll capture everything going there. Okay. The other issue where this may be in effect is when you can use actually permanent ARP entries, and I'll talk about what those are in a few minutes. That's when you actually specify, and at least try to specify, the IP address tied to a certain MAC address and hope that the system keeps that in its cache and doesn't allow anybody else to overwrite it. Now, session hijacking and man-in-the-middle attacks. Obviously, if you can sniff a connection, you can manipulate the contents of the packets. This is pretty easy. The nice thing about this is that you don't have to deal with any type of synchronization issues because you actually have full control over the connection between the client and the server. Okay? All the things with ACK storms and synchronization, et cetera, it doesn't matter because you can do whatever you want to this session stream. Okay, so it makes life a lot easier. It's not, obviously you have the whole issue with making sure the packets and the headers and the counters and synchronization things actually align, but it's a lot easier because you aren't always fighting with either the client or the server trying to resynchronize things. Okay. Now, denial of service is kind of fun. Basically, you can spoof whatever you want to with respect to MAC addresses. They can be either valid MAC addresses or invalid MAC addresses. That means you aren't limited by the type of protocol anymore. You don't have to rely on just sending resets to kill TCP sessions. You can kill ICMP sessions, UDP sessions, or TCP. And you don't have to mess around with looking into sequence numbers, et cetera, et cetera. You can basically, if you can find the person's MAC address, you can just whack the connection. We'll show that in a demonstration later. Okay. Here's an example of a DOS MAC entry. Basically, the attacker has decided to kill Alice's connection to Bob. So basically, generate a bogus ARP response back to Alice. Alice cached the bogus ARP response. And now, for some reason, Alice, if she would look in her cache, would see that she has an entry for Bob for ABC123 for its MAC address. Okay. Now, we found all sorts of fun doing this in either our environment or lab environments or class environments. For instance, as we talked before about somebody wanting to surf to the internet or access the internet or access systems, the easiest way to kill them is basically identify what their MAC address is and generate a spoofed ARP response back to them. So two options would be either just change their gateway address, so you want to knock them out from talking to the router anymore, or you can kill their address to the DNS server, so they can't talk to the DNS server anymore. Okay? Now, some people brought up, well, you know, eventually the ARP cache will expire, you have to repopulate, et cetera, et cetera. I mean, that's fine. Obviously, the tools can take care of that. Sometimes it'll range anywhere from a minute to 5 minutes. It's very operating system dependent. Now, IDS systems have been a lot of fun as well, because most people don't set up their IDS systems quite correctly. The worst thing you can do to an IDS system is basically make it single-homed. Because obviously, any time that the network engine, we're talking about network-based IDS systems here, has to talk to the console to report what's going on, it could be traversing the same hostile network as the attacker. So in this case, if we realize that there's a network-based IDS system out there, we can identify where it is and what it's doing, and basically spoof the destination to the router back to the IDS system. Or if for some reason we can't actually corrupt the cache on the IDS system itself, we can just spoof the entry for the IDS system back at the router. At that point, we'll actually kill the connections to the console. So even if the network engine does pick up the attack, it can't actually report it back to the console, and nobody knows what's going on. Now, this is fun also. We'll talk about this a little bit. If for some reason a hostile user is scanning yourself or another target, we played around a lot with this for Nmap. For some reason, I'm not picking on Nmap at all. This is probably applicable to other scanners as well. Every time it sends out a packet to you or to the destination host, for some reason it does a lookup on the Ethernet address and in your cache. So if you can detect that somebody's actually scanning you, you can send a bogus response back to the attacker with a bogus MAC address for you and actually kills the whole port scan. Because at that point, it's actually scanning nothing. Okay? So eventually it just gives up and goes away. And you can do the same thing for other systems as well. Now, switch attacks are fun as well. Obviously, a switch has a limited amount of memory trying to map the IP addresses to the MAC addresses and keeping MAC tables. Obviously, there's a heck of a lot of possible MAC addresses you can use. For some reason, some switches fail if you send them too many MAC addresses. Now, in some cases, the switch will actually fail open, meaning if you send it too many MAC addresses, it actually becomes a hub. Okay, there's no more switching that takes place, everything talks to everybody else, and it gets kind of ugly. In other cases, we know that Netgear switches will actually completely fail, period. Although the lights apparently come on and no traffic goes anywhere else, you actually have to pull the plug and start all over again. Okay? And we haven't done a lot, I guess, with Cisco switches, but there has been, I guess, some performance issues once you actually start filling up the tables. Now, this is probably the most devious thing, and we haven't done too much of this yet. If you can think of viruses and Trojan horses and things, probably the worst thing that could happen would be somebody build a network bomb. Basically, what this tool will do is sit there and passively or actively collect ARP entries across the whole network. Okay, at a given time or a given timeout, it would take all those ARP entries and basically transmit or spoof ARP responses to all the entries it picked up. Now, I know, at least on our, for some reason, our Deloitte network, they've subnetted it such that we're seeing, you know, at least 3, possibly more Class C addresses all on the same network. So if somebody were to use this on our network, we could actually take out at least 3 to 4 different Class C networks or Class C address spaces. Okay. And there would be no actual defenses against this, as we'll show you in a few minutes. Now, as far as what systems are vulnerable to ARP caches, or ARP cache poisoning, basically, if you're running on a Windows environment, you're screwed, okay? There's nothing you can do about these types of attacks. AIX and HP, Linux, I'm assuming most of Linux is, FreeBSD, Cisco, and Netgear as well. I put in the versions that we've tested. I'm sure most of the other versions are vulnerable as well. Okay. Yes? I'm guessing, yes. Yeah. We actually tested a Pix. I don't know what version the Pix was. But that went down as well. So. I'm sorry? It runs some version of iOS, yeah. We actually set it up. We had an attacker sitting outside of a Pix talking to the internet gateway. We basically were able to corrupt the ARP entry for the internet gateway and basically brought the firewall down. Okay. For some reason, Sun Solaris will not allow you to overwrite the existing entries. I'm still not sure why. If anybody has any ideas, I'd be interested to hear about them. And that's what we talked about, when some systems don't allow you to overwrite or have the ARP entries and you're getting the one-dimensional or one-direction streams. If I have a Linux box talking to a Sun box or a Windows box talking to a Sun box, I can only grab half of the session when we're doing the relay-based attacks. Okay, yes? What was the last part? Okay, because when we would yeah.
For operating system support, cluster or failover servers, how do they achieve that and still not be vulnerable to this type of vulnerability?
So the question was.
Corruption. So if I have two servers that appear as one in like a failover situation, they rely on the ability for a network card to fail over, right? So when one system falls over, you switch over. If you're going to have to tell everyone else to go to this MAC address.
Because the question is, if you have two servers kind of in a fault-tolerant configuration with two NICs, and so if one server falls over, it automatically rolls over to the second NIC. Well, I guess what can you do about that as far as attacks?
Or how, if your cache is non-placeable, how can you fail over?
You probably actually can't fall over. At that point, from a bad guy perspective, you try to identify what it's talking to. So the problem is, even if you're running on a Sun environment, a pure Sun environment, we can't take the cache out. Once you try to leave that environment, talk to anything else, we can take those points out. Okay. So instead of actually attacking the Sun servers, we'd probably actually attack the switch or the routers, talking to that. So it'd make our life a little bit easier. Yes. On Sun, I'm not sure the exact time. I think it's a couple of minutes. Most systems, it's a couple of minutes. 5 minutes, somebody said? Okay, 5 minutes. We just tested on Solaris 2.8. I'm assuming it's really based on the stack, the network stack, so these systems, or the versions below that, I'm guessing are safe as well. I'm not sure. Okay. Yes?
I believe you can still do Sun Solaris, but you have to catch it when it expires.
Yes, right. If it expires, I think if you can do it, it's more of a timing issue. If it actually sends out a request, you can spoof the reply coming back, then you're okay, because then you basically replace the entry at that point. Because there's no authentication or integrity mechanisms built into ARP, so the first one it gets back, it's going to take. Okay. Anything else? Okay. Okay, let's talk about countermeasures. First thing that would come to mind are firewalls. Most firewalls don't do anything at the ARP level. So basically, standard simple firewalls, freeware firewalls like IPFW and IP filter by Darren Reed, those aren't going to protect you against ARP attacks. Okay? So even if you have ping turned off or ICMP turned off and all the other types of things turned off, we're still going to end up taking you out because we're going to get in below the radar of the firewall. Windows environments, we've played around with network, the Black Eyes product. It actually raises the flag that something weird is going on, but what it detects as the attack is not actually true. It basically says duplicate IP address is the warning, but obviously it's not going to do anything for you. You still fall down. Session encryption, somebody came up with. I mean, session encryption, such as VPNs, IPsec, anything else, SSL. Obviously, if you're doing some type of relay attacks or a sniffing attacks, it's going to prevent against that. It's not going to do anything against denial of service attacks. Authentication is not going to do anything about anything else because we still have full control of the stream. Now, Cisco switches. A couple of months ago, I saw on one of the mail threads, somebody was complaining about ARP cache and ARP poisoning. And somebody said, well, why don't you use the port security option on Cisco switches? What that does is basically allows you to restrict the type of source MAC address entering into the switch. Okay? So you can actually hard code or specify the MAC addresses tied to a given port. So if you always know a certain system is going to be tied to a certain port in the switch, you can place it in the entry. If another system tries to actually hook up to that port, it's going to identify and basically shut the port down. You can use it to send alerts, alarms, establish the timeout so it may come back up again after 5 minutes, et cetera, et cetera. Now the problem with this is it only restricts the source MAC addresses, okay? Now, that doesn't do anything for ARP relay attacks. Why? Because you need to use your own source MAC address to actually do the ARP relay attacks because you want the data to come back to you in the first place, okay? Certain types of source spoofing attacks. Let's say I'm a bad guy, I want to generate millions and millions of bogus ARP replies across the network, but I want to try to hide my tracks and spoof my source MAC address for some reason so it can't be tracked back to me. Obviously, in this case, the port security would help in that case because it would actually pick up the bogus MAC address, trying to leave that port and enter into the network and then shut it off. If you're trying to use just general denial of service attacks and you still want to use your own MAC address, this isn't going to protect against that, okay? Because you have a valid MAC address leaving that port, entering into the network, so the denial of service packet will still work. Now, what about hard coding addresses? There's a way, it's usually ARP minus S and then the IP address and the MAC address. You can do it at the command line to actually try to permanently or manually add entries into your ARP cache. Now, the problem is that is just a nightmare because you actually have to identify all the systems you want to talk to and try to set that up. So that you have a scalability issue. The other problem is, for some reason, some operating system vendors don't support that. And here's basically what we found. If you're on Windows, once again, you're screwed. All right, you type the ARP minus S, it'll actually add in the static entry, it looks good, but as soon as a new packet comes in, it's going to overwrite the existing entry, and you're back to square one. Linux and BSC, which we tested, they actually allow you to permanently add the entries in, and once another packet tries to come in, overwrites them, it just ignores it and drops it. Okay. So quickly, the summary. For some reason, hard coding is basically the best defense, but it's not consistent. Because if you're running in a Windows environment, you're in trouble. BSD and Linux, and I haven't tested the other Unixes yet, you may have a little bit better luck. As you'll see, in all cases, denial of service is probably the worst thing that you're going to encounter with MAC addresses. Okay. Port security does a little bit in terms of sniffing and session hijacking, et cetera, et cetera. But basically, the denial of service is really the key thing. There's really no way to get around those types of attacks. And what about detection? As I talked about earlier, people set up really poor IDS systems are just going to get their pants taken down. And we see this again and again and again, that they put their network engines on a single home box on a hostile network. Okay? If we see that, basically all we do is just cut off the connection between the network engine and the console. The best thing to do is basically dual home the network monitor and run a separate administration network, security network, whatever you want to call it, so that there's no way for the attacking system to actually take down the connection between the engine and the console itself. Now, we actually did test some IDS systems, but because we don't have enough disclaimers and whatever else, I can't really go into those, but if anybody's interested, I can talk about those offline. We tested ISS and NFR and NetProwler and Dragon as well. It had some interesting results for those different IDS systems. So OS level detection. So what operating systems are going to realize that somebody's smacking you? Well, basically nobody, for some reason, except BSD. BSD will complain and say, hey, this station is trying to switch its MAC address. And basically, if your syslog is set up by default, it'll broadcast it across the screen, or at least make an entry in your messages file or wherever you want to put it. Okay. Of course, if you don't have a permanent ARP entry, it's basically saying, hey, somebody just pulled your pants down because it's warning you, but it already happened. Okay, and you basically have the entry in there. We haven't actually tested on Solaris. I don't think, when we did the test, I didn't see anything show up in the syslogs. It just kind of ignores it, yeah. Yes?
When it actually detects it, what sign do you get?
When it actually detects it what?
When BSD does the test, what do you get that says they're detecting it?
I think it's built into at the kernel level. You actually get a little messages dumped out to the syslog facilities saying station X at this IP address is sending you this MAC address. Tries to overwrite it. Okay. I'll actually see if I can show that when we do the demonstrations later. Linux, by default, does not. I haven't actually tweaked the Linux syslog.conf file, but it does not pick it up by default. Okay, so what else can we do? Well, hypothetically, some type of defense would be basically an application which would detect and maintain mappings between the real IP addresses and the real MAC addresses. And if for some reason it could identify, the non-standard ARP replies versus the acceptable ones, it would basically generate replies back there. And the key issues that we found with this is that obviously the operating system has to withstand corruption itself. Yes, go ahead. Yes, and I'll talk about that in a few minutes. Yep. The other issue is that the application, it'd be really nice if we could actually fix the broken ARP entries. Okay, so not only would it have to maintain the valid ARP entries, but it can actually go out to the different systems and fix the broken ARP entries on the systems. So, of course, there is no application that does this quite yet. So as far as tools and utilities, dsniff and hunt are probably the most common tools out there that use ARP and ARP-based attacks. dsniff is written by Doug Song. Basically, it's a sniffing utility. It works fine across hub networks or switch networks. It actually has an ARP relay capability built in. I encourage any of you, if you haven't used it before, to go out and use it. It's pretty neat. Hunt, written by Craw, is basically a session hijacker. Okay? And it also has the ability to do sniffing and session hijacking on switch-based networks. Okay. Some people complain about the GUI, but it's a pretty good tool as well. Basically, you can go out, you can grab MAC addresses, you can grab the sessions, control the sessions, and basically do the ARP replies and spoof replies as well. Okay. Now, there are a growing number of others which I've seen out there. I believe there's actually one tool that I've seen out there, I cannot remember the name offhand, that actually works in NT right now. I haven't actually tested out in NT yet, though. Yes?
T-site.
It's what?
T-site.
T-site? Yeah, T-site, that's been around. What? Snarf? Snarp, S-N-A-R-P? Okay, so Snarp and T-site. I think T-site was the old UnGuard product. Is that right?
Yes.
Okay. Monitoring, somebody just mentioned ARP Watch. ARP Watch has been around forever. Basically what it does is it maintains mappings between IP addresses and MAC addresses. And the unfortunate part is it actually uses sendmail to notify you when it happens. So by default, Linux has it installed. If your sendmail is configured, it kind of complains a little bit. So basically, the key thing with the ARP vulnerability is it's very simple, it's stupid. ARP has been around since 1982 when the first RFC came out. Okay? It has a great deal of annoyance potential. All right? There's very few defenses about it. Obviously, if you're in a Windows environment, you should be pretty concerned. Okay? Because there's very few things you can do about it at this point. Probably the best thing that we found is really identifying when this is happening, but very few people actually look at their ARP cache, and we'll show you in a few minutes, when you actually do relay-based attacks, there's very little that shows up. Sometimes there's a little bit of a lag in the session, but again, it depends on the system and the way the network's working. Okay. With respect to some things to read about ARP, I have the URLs for both the hunt and the dsniff out there, as well as the references for the RFC. Those are good sources to read about. Okay, any quick questions? Yes? Proposed solution. Honestly, I think the best solution is really the detection application, response application, because I can't see the operating systems all going out and recoding their stacks to prevent this unless they do something similar to what Solaris is doing. Yes?
Did you check to see if any of the versions of FreeBSD prior to 4.2 were able to detect?
Detect or prevent? 4.1 did. I want to say 3.4 did as well. I'm not sure of anything below that. I first started this back in 3.1. So 4.3 also does pick it up as well. Okay. Any other questions? Yes? Right, that's the key thing. This is a local network-based attack, okay? Somebody actually has to get in there and be able to see the local-based MAC addresses. So once you pass through a router or something, it's all over, okay? It doesn't matter. And that's the key thing. But the concern is, if people can put in viruses in your machines and Trojan horses, then they can do this as well. So that's where the concern lies. Yes? Well, in this case, the TTLs actually don't change because the attacking machine, all it does, and I'll show you a relay I wrote, it basically takes in the packet, and all I do is take the packet and just switch the MAC entries on the packet and then ship it right back out again. So I don't tamper or touch anything else within the packet itself. Okay? Yes? Okay, so the question is, can you actually change the ARP entries on one interface for another interface? Yeah. I did not test. I want to say no for some reason, just because it's passing from one segment to another segment, and the router will actually try to block that. I'm sorry? Okay, someone says Cisco won't take that. Okay. I think if you had a bridge for some reason, you're actually passing the ARP entries back and forth, you might, but there's no reason to do that. Okay. Yes? Okay, the question is if you can actually identify all the MAC addresses, ARP addresses on an internal network, couldn't you actually poison the gateway router for that entire network? Is that right?
Actually, if you identify the IP address, it's just made up of only ARP entries to the gateway router.
Okay, so you can actually identify the IP addresses made up of only gateway entries for the router. The key is you'd actually have to get the bogus ARP responses to the router itself and pass on to the network. Okay, so if you're not, unless that router is for some reason passing ARP to the other segment, it's not going to pass it back through. Okay? Any other questions? Okay. Yes, sir. With systems. Okay, so the question is, in BSD, it complains a lot when you actually have two NICs sitting on the same hub. Now, have we checked that with other systems? I have not checked that at all yet, no. It's a good question. Are there other questions? Okay. Okay. Yes?
It's actually more of a statement question. I know certainly if the Solaris and Linux, it's actually disable altogether, and it's actually with the theories, which is a possible solution. But I mean, if you've got sort of a handful of machines, it's just an admin nightmare. But if you only have 2 or 3 machines, those are the times and
Okay. Yeah, the statement was one way to actually disable ARP on Linux and Solaris and just use the local entries, which obviously would prevent against this type of attack. So that's true. Again, the key thing is it's a kind of a management issue because you actually have to know all the different MAC addresses across the, that you're going to be talking to. Okay. Any other questions? Yes?
I'd like to throw something out. Since you didn't test any real IDSs, Snort has an ARP processor that will detect all of this. And it can take about 20 minutes for the code to actually have it take back responses so that your ARP cache is fixed.
Okay. The comment was about a Snort. It's a real IDS system as opposed to the other ones we were talking about, which is probably true. Don't tell the vendors that. They can actually reprogram it to actually send back MAC addresses as well. Yeah, it could. Right. And the interesting thing is one of the tools I have, I'll show you, it actually maintains IP address pairings, both for the valid IP address MAC pairings as well as the bogus ones. So when I actually issue a bogus MAC address, it still knows the real MAC address. So it'd be just as easy to actually go through that list and reprogram everybody's MAC addresses to the correct addresses. So, right. Okay. I know there's been a lot of questions I've seen on mailing lists as well as, can you spoof your own source MAC address? And the question, or the answer is yes. I know in BSC there's a certain kernel file you need to go through and actually change and tweak, but then you can create any type of MAC address you want. I know there's been a lot of questions about how do you do that, is that possible, et cetera, et cetera. So you can spoof your own source MAC address. Okay. Any other questions? Okay. Yes?
Have you looked at anything with Linux with bonding of the two network cards bonded together with virtual networks?
Okay, so the question is, have you looked at Linux with two network cards bonded together with the same IP address, with MAC address?
Well, virtual MAC address.
So the same virtual MAC address? No, I haven't looked at that. Okay. All right, we're going to try to do several type of demonstrations. We can keep our fingers crossed. Oh, right. Did you switch on it? Hold on. I can program, but I can't do it. Let me show the demo first. I know, I want to show you the demo first. Let me show you what the demo network looks very quickly. As you can see, we have several different systems on here. We have a Red Hat system. We have the BSC 4.2 system, which we'll actually use to attack all these other poor boxes. We have another, it's actually a Win2K system top than 10.40. We also have a Win2K system operating over a little wireless network into the switch as well. We're thinking about doing this on the wireless network out here, but I'm having trouble getting my Cisco card working under BSD. So if anybody has done that yet, please, there's a book up here for somebody. So it's just a nightmare. All right. Okay, this is Kevin Kyle. He's going to be, he pulled the short straw. He's going to try to help me on this. The first thing we're going to do is, what I mentioned a scenario about doing web surfing and killing web surfers. So Kevin's going to actually surf to the Linux box here, which is on its last leg, so I hope it lasts through this demonstration. So basically it goes through and sets it up. Which one am I using? that's a web page we like to use when we, kind of for when we break into client systems. That usually gets their attention. Okay, so the first thing I'm going to do, if you can see the menu of the people in the back, there's several different options here. Instead of using ping or anything else, I'm actually going to just use pure ARP for this tool. So basically what I've done is I've gone through and I've gotten Kevin's MAC address off his box. Okay, so basically I type in the target IP address that you can see at the top of the screen. It generates an ARP request message. And if I'm lucky, okay, let me pull the screen down. You can see at the top right now, I have an ARP list going. Now this system is actually also operating in passive mode as well. It goes into either active or passive. The whole time this tool is running, it's looking for ARP broadcast requests that go across the wire. So anytime another system is trying to reach another system or their cache times out, it'll actually pick up the broadcast message and fill in this little list, which was fine until I put it on a network that had the 3 Class Cs running on at the same time. I need to fix that. So now that we have the, Kevin's MAC address, oh, nice. You'll notice the wireless network that for some reason we're bridging it on the bottom. We'll leave that one alone. We'll pick Kevin. Now for the spoof source, we're going to actually pick the web server. So put in the bogus MAC address and kick it off. Now, hopefully if this works, Kevin will actually try to go back to the website and he will get no love. We'll pull up your ARP cache. And if he pulls up his ARP cache, can you see it? You probably can't see it at all, but you can actually see the bogus ARP entry in it, the ABCDEF. Okay. Okay. So the other option we could do, again, is if for some reason the web server was not local, we could do the same thing for the router. We could either spoof his address to the router or spoof the router's address back to him. Okay. Good. Now the second thing we're going to try is the actual relay application. Now this tool is called ARS for the ARP relay system. Okay. Basically all this does, when I was running these tools, the one thing I was concerned about was performance with respect to relays, all right? Because obviously if you're not only sucking packets in, tweaking them and spitting the packets out, you want to do it as fast as possible. So this is actually a pretty stupid stripped down tool. All it does is just relay packets back and forth. The other thing this does is it actually captures all the data as well. The other option is you could actually use TCP dump listening on the interface, because once it actually sets up the relay, you're going to be getting all those packets. Then you can just run TCP dump, it'll basically snarf everything out, you can decode it and manipulate it later. Hold on. The person who set up the wireless network is going to be in trouble, because we could hurt somebody here. So Kevin's going to tell that into the Linux box. Okay, so now basically what I've done is I've typed 2 IP addresses for the box. So what I've done is I've not only typed the MAC address of the Linux box, we've also typed the MAC address of Kevin's box as well. So at this point, what the tool basically does is it goes out, requests the MAC address of both systems if it doesn't know it already for some reason. It sends the spoofed ARP responses back to those systems with my MAC address instead. At that point, then my poor little box here will have to take all of Kevin's packets and basically relay the stuff back and forth. And he killed it. Nice. Yeah, hold on.
No, it killed it. Do what?
Are you done? Nothing? All right, we'll come back to this one later. All right, the next demo we'll try, as soon as I fix this and come back here later, we're going to try the DOS attack.
Yank the wire.
This one we're going to do is actually go out and grab all the MAC addresses of the systems on that network. Which actually, as you can see, it's operating in passive mode, so I'm grabbing them already. So you can see I have the two 10 networks are going to be from the wireless network, which for some reason we're picking the traffic up on. And the two 172.16s are actually the other addresses. I'm not sure what the 30.250 is. That's somebody else. Our wireless station is operating in roam mode, as you can see. Okay, so as you can see, we now have entries for 6 different systems in our ARP cache, the ARP table up here. Basically, it's nothing more than a linked list doing the maps back and forth. The first column is obviously the index. The first column the second column is the IP address. Third column is the valid MAC address for those. The fourth column is actually the contents of the ARP packet that we picked up or snarfed off the line. So we have 25, which is me, index number 2, 10.30, which is the Linux box, 10.133, which is this box the presentation was on, and 10.40 is Kevin's box. So basically at this point, what we can do is either send bogus MAC addresses to the entire list or do basically point attacks on each one of those. Dump your table. So I've DOSed at this point not only the Linux box as well as Kevin's box as well. So at this point, these boxes will not ever talk to the default gateway ever again, at least until their ARP cache expires. So the other nice thing about this tool is I actually have the ability to dump out the ARP pairings. It's mostly just for a statistics collection. And the send bogus MAC to the entire list, number 2, there's several different options for that right now in the tool. It'll either go through and pull every system out of the linked list and allow you to specify a given bogus MAC address, send it back, or it actually allows you to go through the entire list, take the entire list again, and generate random MAC addresses and spoof it back. What this does is basically, for every person's ARP cache in every box, it'll actually corrupt every other entry to the other systems on the network that have talked to you at that point. Okay. So it's a flurry of ARP activity, but at that point, pretty much the whole network is down. So. Okay, the last thing we're going to try is nmap. And again, as I mentioned about nmap, every time for some reason nmap sends a packet out across the wire, and it's other systems as well, anything that uses sockets for transmitting packets, it always gathers the Ethernet material out of the cache, and it generates the packets and sends it across the wire. So if you can actually catch nmap in its scan, you can actually send a bogus response back to nmap, and then actually kill the scan. So in this case, I know it's coming from the Linux box, which is 172.16.10.30. The source I'm actually going to make myself. So Kevin's going to actually kick off the scanner. And then let me know when he's going. Okay, so at this point, if we can actually bring Kevin's thing up, which I'm not sure we can, nmap has basically started the initial scan, okay, and as I'm caching the packets, I actually send a bogus response back to him. And basically, at this point, the scan is still going on, if I can run a sniffer here, but the packets are actually going to a different bogus MAC address, okay? So the scan still looks like it's working, but the person actually initiating the scan is not going to get anything back. And we're trying to figure out what's the best way to do this. We figure we're going to write a separate tool that basically allows you to specify what ports are valid that you're going to listen on the machine, and anything else, any type of incoming connections, SYN packets, et cetera, anything else. If you receive those and those ports which are not valid, you'll basically spoof the MAC address of yourself back to the originating machine, which will then block any more scans after that. Okay. That way you don't have to sit around here and wait for the scan to start, identify it, and then kick it back. It'll all be automated. All right, are there any other questions? I'm going to try this relay thing again after that on some of these tools. Yeah, at this point, I'm not sure why we're still picking up the wireless network in here. And there's actually some other addresses that are showing up as well. Obviously, number 8, the 169.254.207, that's somebody running DHCP on the wireless network. And the rest of these people are on the wireless network outside. Sorry? Is logging the keystrokes on both sides, you're asking? Yes, it actually picks up the entire packet. Right now, I have the ability to run TCP dump and stalk the connections. By default, this will actually pick up all TCP connection and it dumps it out to a socket file. Basically, it has the source IP, destination IP, as well as the port connections, and it dumps it out in ASCII. Any other questions while we're fixing this and trying this again? The first tool is called ARS. That does the relaying, the ARP relay system. The second tool is called FARP at this point. Yeah, somebody keeps asking what the F stands for. Smart people. Okay. Any other questions? Yes?
If you overload a switch, does it overload, does it just make that one switch port pop up, or does it make all the switch ports on blocks?
The switches that we tried, it actually makes the entire switch, these were single switches. These are not in something like a catalyst with umpteen different blades. These are just single switches. Made the entire switch a hub at that point. We haven't tried it on a catalyst. We tried it on a, let me qualify that. We tried it on a catalyst, and the biggest thing we could notice we were generating the ARP replies was just a real big performance hit. The thing slowed down to a crawl. I think because it actually had to go through the entire ARP table and identify where it's going to send the stuff. Okay. Yes, another question?
Experience with Intel Ether Express switches in regards to this workflow?
No, I haven't used those. The question was, have we had any experience with the Intel Ether Express switches? And the answer is no. Any other questions? Okay. All right, we'll try this relay thing again. You in? Good connection. Yep. You got the MAC edges, both out of your clean Macs. The nice thing about this tool when it works, actually, is that once you actually switch the MAC addresses to yourself, when you actually exit the tool, because it keeps copies of the valid MAC address, it'll actually go back and fix the MAC addresses. So there's actually not even a blip on the connection. Can we run? Ah, joy. All right. Okay, it's actually working, finally. Apologize for that. Let's see here. You'll notice that within this directory, there's two files, .log files. Okay, these are, each file is connected to one end of the stream, or one direction of the stream. I know there's obviously a nice way to put this and merge this all together so it looks in one cohesive file. But at this point, this poor box is now relaying all the information between Kevin's box and the Linux box. So you can see, this is everything that Kevin is seeing as he's going through this. And this is everything that Kevin is typing. Obviously, with the logins and the passwords, you don't get those echoed back. We see he typed in the username Robert, the password Bunnyman, and then these are all the commands that he's typing, okay, through the actual screen. So basically at this point, we're just running a tail on the file itself. So everything he types, we're picking up. So, okay. Now that I have demonstrated this actually does work, I'm going to go back to the original tool itself and actually kill it and stop the relay. Do you still get love? And Kevin still has love. So he's actually still logged into the machine. Okay? So it didn't actually kill the connection. So and at that point, I just have the logs of his session on both sides. Okay? Questions? Where's the tool available? That is a good question. I'm going to try to push this out momentarily, as soon as I clean up some of the interesting bugs. If you're interested in the tool, my email address is on the slides as well as it should be in the presentation. Just send me an email. I can let you guys know. It's probably going to be just on some, I'll probably just put it on our website somewhere. Okay. There's some of the things I want to actually add into the tool is building in the TCP packet capture right into the relay itself, so you don't actually have to run it separately. Right now I just picked the ability to just log TCP connections in the relay, but I'll probably just do it raw, so you don't have to run it twice. And then the other tool, the FARP tool, which does all the denial of service attacks, there's just some GUI things that need to be cleaned up and some interesting functionality I'd like to add into it. So, okay. If anybody has any ideas or questions or anything else in the tools are more than open for comments as well, except in the coding. So, okay. Yes?
What's the email?
Email's not there. It's, let me pull it back. It's mbeekey@deloitte.com or beekey@clark.net. I'll pull these things up here. There's the email addresses. So either works. Any other questions? Okay. Well, thank you very much. The next session I think is going to be similar. It's also going to be an ARP and ARP attacks. So you can get even more ARP love this afternoon.